And apologies from the start, there might be some of these slides a bit busy, but it's just the general idea that I'm just trying to get across. So I'm just taking this opportunity to try and explore the biology of salmon in the sea for myself. So really this is a kind of selfish kind of thing. If you guys get some benefit out of it, all the better. So I just had to show this slide. Everybody showed some version of this. This is the most recent working group report from ICES, and just shows the decline. So this idea, why might we want to look at the sea? Why is it important that we might think that something is going on in the sea that might give us some insights to this phenomenon, this decline. It is interesting that in Iceland, particularly for the one sea winterfish, that doesn't seem to be, it seems to be quite stable over time. So, there's a dynamic there, and that might be something we'll discuss a little bit later on. This space is busy. Do you know something? I'm going to come down here to see what the hell's going on here. Yeah, so this is a busy space at the moment. And really what I'm showing this here is that if we're going to start looking at the sea, what are the main challenges? What is it that we want to look at? The other thing is, it's very early in the process. The technologies are quite new. Like we're talking maybe 10, 20 years. And people have been thinking about the life of salmon at sea. And there's the likely suspects framework we've heard several times in the last day or two. That it's important to locate the fish. Where are the domains? Where are these processes that might be impacting on the life history of the salmon? Where do they occur? There's some fantastic data. I think these are going to be available after the meeting, but if you could get a chance, you could read some of these papers. There's some fabulous summations and reviews of the state of knowledge at the present. Okay. I thought I'd put this little slide together just to articulate the challenges that might be there and to identify where I see at this moment probably the most important pillars. And there are two pillars I think that are important here. One is the location that has been advocated by many of these reviews. Where are the fish in time and space? Where are the post-smolts? Where are the adult feeding, the pre-adults? What are the migratory routes? What are the feeding aggregations? Can we locate those? The other is to make them stock specific, population specific. 2 or 3 of the two presentations this morning talked about stocks, the biology of those stocks, the life histories, the variation of those life histories. So we're talking about location, we're talking about origin, but within that, there are a whole lot of issues. Population responses, the drivers of those population responses, so what's going on in the sea that might be driving these things. The attribution of the impacts. When I mean attribution, how much is due to natural processes? How much is it into anthropogenic changes in the ocean environment? Adaptation. Talked a little bit about this yesterday when Jim asked me the question. So how do we respond? What is adaptation? And there may be some surprises there when you start to think about how you respond to these things. And then prediction. What is going to happen in the future? Do we get any insights of forecast? And when we think about location, we're thinking of migration routes, we're thinking about foraging and feeding areas, identifying those. They're quite different, quite distinct, but I hope I'll show that for different populations. And from an origin point of view, from a population-specific point of view, it's about the hard wiring of those traits. How much of those traits are due to local adaptation? How much of them are specific to the stocks that are involved? The life history variation we talked about it this morning. Those, sea age, run timing, the locations these fish are feeding, these are all important parts of that. And one thing about resilience, I just thought about the resilience when we're talking about this. There are 3 options for the fish in these changing environments. One is they can move. That's probably the easiest thing to do. We'll move. Go somewhere else. Won't go to the Bay of Fundy. It's not great. We'll go somewhere else. Go to Ireland. Go to the west coast of Ireland for our holidays. Go to Iceland. Get into a little river in the northeast of Iceland. Anyway, or go to the sea of the Labrador Current or someplace. The other thing they can do is they can adapt. But adaptation comes at a cost. There's often a demographic penalty due when this adaptation takes place. They can adapt. So they might, they might be best matched to a temperature of 15 degrees in the ocean now, or 8 degrees in the ocean, but maybe they could adapt and survive at 9 degrees or 10 degrees, that kind of thing. Oh, the other thing is they can die. Just, we have a mismatch with this environment, can't survive. Therefore, the kind of responses that we see are due to that kind of thing. So back to the stock structure, a little bit more on the origin stuff. I got this beautiful slide from Jaco yesterday. I just had to harass him there last night, any chance of getting it. And it was much more colourful than the one I had on the Moy, so I thought I'd do that. But he articulated very well yesterday that the relevance of all this stock structure, it's all linked to the life history variation, all that structure, that portfolio of capacities, that genetic portfolio of different responses to the ocean. Every river has its own distinct population. Every river has its own distinct population, and they're very different. And they have different life histories. And that's what we're trying to protect. That's the basis of the whole thing. And I think one thing that illustrates that really nicely, this is a study from Ray Hilborn in Bristol Bay. I'm not sure if it's pink salmon or sockeyes or whatever, I can't remember. But I thought it was really, really illustrative of what we're talking about when we start to think about marine survival. There were 3 different populations, 3 very distinct stocks used Bristol Bay. I think they go up to the Alhambra Lake. And in the early period, right there, the 1890 is the first point on that. The hatch population there. That hatch population hardly existed. It was very low. And you might think, we could do without that population, say around the 1890s. And then with the changes in the ocean, this Pacific Decadal Oscillation, the PDO, it's like the NAO, it's like the AMOC, all these things that you hear about, these measures of change in the ocean. As that changed, that population now is the main driver of production in Bristol Bay. You see the hatch population. Some of the other populations have declined. But if we were making management decisions about the populations to protect back in the 1890s, we would have protected the grey one or the white one. We wouldn't have worried about the hatch one. But yet it's the hatch one now that's doing the business. And that's the flexibility in these portfolios. So the idea of portfolio comes from this analysis of economics. Spread your risk. I'll have property, I'll have shares, I'll have various assets. You spread the risk, and that's what the salmon are doing. That variability spreads the risk and allows resilience in the populations into the future. Don't worry, this slide is very busy, but what I was really trying to get at is the response. What are our responses? What are we talking about population responses? We're talking about abundance. That's all the slides we've seen. Everybody showed the same slide. Oh, abundance is going down. This is from the Don commercial fishery. That first point, that first little box is 1770 to 1810. And look at the productive potential of the system then. It's about an order of magnitude bigger than it is now, presently. Okay. The second box, the lower slide, is from the Foyle River in Ireland. And you see the box, it's the decline there. So the decline there is from about 1985 or 89 or so, the kind of ICES, the plots we see for ICES. But if you look back in history, back to 1870 and so, that peak we've seen in the 70s, that was a unique peak in that period. So when we're starting to measure these and assess these things, you have to have some cognizance of the history of the productivity of these populations. And it's quite often cyclical. Grills to salmon ratio, sometimes grills predominate, the ones who went to fish. Other periods of time, as you would see there, salmon predominate. Run timing is changing all the time. Sometimes the stocks are earlier, sometimes the stocks are later. It could be genetic, it could be a plastic response to the environment, but this is the capacity for these populations. We're going through a period now, size and age, that should have been, actually one of them should have been condition. So the condition of the fish is low, we've seen that over the last year or two. The size of the fish is changing. So these things are changing. These are the responses that I'm talking about. What are the drivers? That top left-hand corner, that is the sea temperature around the Voreen Plateau presently, or in that period over the last 20, 30 years or so. There's a very distinct period of warming. That's measured. That's an empirical measure. That's something that could be driving these population changes. The ecosystem is changing all the time. We talked about different prey species. We talked about the zooplankton. We talked about phytoplankton, moving it up through the ecology. We talked about the ecology of the rivers Guy talked about the ecology of the rivers. The exact same processes, the exact same dynamics, the exact same biology is going on in the ocean. Sometimes you have a predominance of one part of the trophic chain, sometimes you have something else. It could be anthropogenic. It could be fishing. And you see these lines, that orange, the intensity of the orangeness in that little box there in the corner there, I wish I could point it out. That's fishing in international waters, outside the economic zones. So there's a lot of activity actually going on. It could be fishing that's causing some of these things. It could be a human thing. Or it could be a natural phenomenon. Those cycles up there, you see the ocean there and the path, that's the Gulf Stream, that's the energy, the heat energy coming up from the Gulf Stream into northern waters, into the northern Atlantic, generating the production. And that is cyclical over time. And you can see that in the measure there. Attribution. So a big, big challenge for biologists at the moment to see is, can you partition out what is due to, say, global warming or anthropogenic change or heat into the environment versus what is natural? Like I often thought, well, I'm just naive thing. I often thought the cycles we see was a great hope for the future of salmon populations. You know, they've been depressed in the past, quite depressed in the past. Quite often they've come out of those periods and they've gone into another period. So it's very important, if we're really going to understand that and predict that into the future, that we're able to disentangle those two things. And where a lot of the science is driving that is in this whole idea of climate litigation. Can you partition out the bit that is due to man, or the big chemical companies, or the energy companies, and what is natural? And that's not easy, but that's the big challenge. Prediction. So we look to the past to get some idea of what's going to happen in the future. What do the managers need? The managers need to know what's going to happen in the future. Can we predict these things? There's a lot of work ongoing at the moment to look into what's going to happen in the future. And there's one set of graphs there on the extreme left, or my left, that shows that this AMOC, which Kevin Friedland and others have suggested is a big driver of energy into the system, that has a big impact on productivity of the fisheries. And that driver suggests that we're going to go into a period that's not really suitable in terms of warmer temperatures for a long time, 20, 30, 40, 50 years into the future. They may be right, they may be wrong, I don't know. There's a lot of effort at the moment. I'm part of a group there, the EasyMIP group, we're going to FishMIP, where we're starting to look at the dynamics of the ecosystem responses in the ocean. And I can tell you from some of the salmon, there are a lot of surprises out there. Everything just doesn't move north. Sometimes it moves west, sometimes it moves lower. But all the time that ocean environment is changing, which brings me back to that, how locked in are these behaviours, these migratory behaviours, these movements towards the feeding ground? How much are they locked into the particular environment? Because if they are very much locked in trying to readapt, there's always going to be a penalty. And maybe that's the explanation for the declines we see at the present. In terms of adaptation, well, I suppose we could stop fishing. I suppose that's one possibility, might help the thing a little bit, or it has in the past. Or quite often, a lot of our coastal fisheries, the populations continue to decline even though we've closed many of our fisheries. We might start to change our industrial or power generation aspect. So these are things, that's adaptation. But there are surprises and there's competition. And when you compete for water, for fish, there are other people who are interested in the water as well. And they may have prior or advantageous or some other aspect of access to that water. Whether that's for flood management, whether that's for power generation, whether that's for utilities, whether that's for drinking water. So you have to think, fish are they're there. And I think myself and Guy were just talking this morning, like one of the things I suppose about the fish is it is an indicator of good ecological quality. The Water Framework Directive that you're probably all familiar with, it's an interesting metric, but how do you articulate it? I think you articulate it through the rivers, the ability of these rivers and lakes to maintain and sustain salmon. All right, that's the first part. That was just this context, I think. Now just get into what I was supposed to talk about. Anyway, look, there is a history, 50 years. There's a fantastic report out recently. A colleague of mine involved in it, Neil O'Malley and others were involved in it. The Code of Wire Tag. a physical tag. Stick it in the nose of the fish, has a number out, the fish go out to sea, and in the big commercial fisheries in Greenland and the Faroes, those tags were picked up and you were able to assign them back to their home. So the advantage was, you could release thousands, millions of fish, recover a certain proportion of them. There was an unequivocal assignment to the place of release. And, maybe there were limitations. Quite often there were hatchery populations. How representative were of the wild populations? There was probably handling issues and all sorts of things. But an incredibly important data set. Satellite tags. A friend of mine, Auden Rickardson, they've recently reported this, their work with satellite tags. And in a way, it's a kind of a cast back to the past, because 60 years ago, Arthur Wendt, who was the Inspector of Fisheries in Ireland, they were putting hydrostatic tags on salmon, kelts, big adult kelts, and then they were recovering them in Greenland and in different parts of Ireland and in Iceland and all sorts of places. And we're back to that now, except this time, that tag, that satellite, disengages from the fish at some stage, preordained, shoots up into the surface, transmits to a satellite, back to the lab, and that gives you the credit. So you get the location of where the transmitter came off, where that fish was, but also you can infer a whole range of information from the environmental data that's been collected on that tag. So there are advantages, the disadvantages, you can only do 10s, 20s, 30s, it's expensive business. Most of the time you get the result. But when you see some of the data that Auden and others have produced, you start to see the magnificent, how the fish are using the ocean. That sense of location, back to the location. It's stock specific because he knows the river that he tagged the fish in. That's two of the big deliverables that we're looking for. Unfortunately, it's only one life stage, and it's the post-Kelt. So the fish has to be big enough to carry such a big piece of equipment. All right, so everything has advantages and disadvantages. Acoustic tags. This is where you set up an array of receivers and you put your acoustic tag in your fish, you send your fish out into the ocean, and they pass the array. So the advantages, it's empirical, it's a physical tag. Probably a disadvantage is only you get the single passing. Sometimes they pass 2 or 3 times it on the way out and the way back. You get an unequivocal assignment to the river. For the most part, it's hatchery smolts. It has to be a hatchery smolt to be big enough to carry the tag. And there's some fantastic data being recovered. There's, again, a colleague of mine on the Sea Monitor program, they're starting to pick up different tags that were released there during the summer. So they're starting to, and there's an array of these between Ireland and Scotland, so you can imagine, all these smolts that are tagged have to pass through this, so we know the timing, their survival rates, we know a range of this whole idea of tying into the migration route. And then you can have these gliders, they're out swimming across the ocean in some predetermined pattern, seeking out the smolts. So again, a very powerful technique. There's another way that you might do it inferentially. There's a relationship between the sea surface temperature and the carbon content of the water. I think it's linked to the phytoplankton production and so on. But you can map the seascape. So when you get the scales back from the fish and adults recover from the fish, from the sea, you can look at the carbon content of it and you can link that back to where that fish might well have fed. There's another way of getting access to that information. It's probabilistic. It's you're waiting for the fish to come back and so on. But you're working with wild fish and you can probably look at thousands of fish. And then worked at Ziggy Good-Johnson here, some of the Icelandic work a few years ago, some fantastic stuff with the data storage tags. Again, information that's recovered from a tag, so the fish goes to sea, you recover the fish, look at the data, and then you have this whole record of the temperature, and you can infer where the fish was likely to have been from temperature profiles. So that idea of scaping. Big advantage of this particular technique is you can do it with smolts. So that's good, you're starting to get an idea of the marine biology. And then the game I'm kind of involved in, to an extent, using genetic tags. And the whole idea there is, we talked earlier about this portfolio, this baseline. So if you can identify the sample from the Moy, have a genetic profile for it, catch your fish at sea, you can assign it back with very strong probability to its river or region of origin. But importantly, and this is the one that always catches the thing out, this is where the debate is, it is a probabilistic thing. So we're all very familiar with it within the legal framework of Some guy commits a murder or whatever, and get his profile, and then they match it to whatever evidence that they've recovered from the crime scene. But in order to put this guy in jail, they need to know 99.999% that that is the guy that did the business. But in a fisheries context, we're probably happy to go with maybe 80% confident. It's more than sufficient for our purposes. An incredibly powerful technique. The big advantage is wild fish, and all the fish are captured. All the fish are captured provide information of the origin of those fish. Unfortunately, it's just 2 points: the river of origin and where we caught the fish. So you have to infer where it has been in the intervening period. Okay, a big study started off at the South Sea some years ago. Big multinational program. Went to sea, collected a lot of fish. Also had access then for smolts that were captured in many, many surveys over the years. And you see in the orange, at the extreme right here, the orange, that is the actual sampling, the trawl sampling, the pelagic sampling that has gone on over the last maybe 30 years in the North Atlantic. So one of the criticisms, I think, at the time of the South Sea project, well, you're just going to a particular part of the ocean. We actually have information for, I don't know what it is, 40 million square kilometres, I think it is. And the different colours or the different intensities of the trawls. Switch over to the left-hand side. That is where we've picked up the smolts, all those different colours at different months. But more importantly, in that whole survey, the little grey, that's where there's been a trawl, but no fish has been recovered. So we can be very confident that these concentrations of fish are where the fish are. Whether, as you see along the west coast of Ireland and Britain, it's a migratory route, or on the west coast of Norway, a migratory route, or a feeding ground. As you see, the fish are mostly congregated around the Vorine Plateau. But what is interesting about that? Some very simple statistical analysis. Observed versus expected. All you guys who've done your statistics at school, observed versus expected. So if we take the three groups here, southern, northern, and Iceland, and we see the grey is what was expected from the productive potential of the rivers in those areas. The white is what we actually observed. You see a very interesting story. The fish that are caught on the Vorine Plateau are predominantly from the southern populations: Britain, Ireland, France, and Spain. Many of the northern populations are missing. It's way underrepresented. Even though it is a very short distance from the coast of Norway to the Vorine Plateau, the fish aren't there in any significant numbers, in any substantial numbers. And in Iceland, which is even closer maybe to that Vorine Plateau, there are substantial underrepresentation of Atlantic fish. That is a very basic observation. So the big question now is, where are the Norwegian fish? So back to this idea of stock specific and location. Where are the Norwegian fish? Where are the Icelandic fish? Maybe they're somewhere else in the ocean. So if you want to know what the processes that are related to the Norwegian and the Icelandic fish, well, you want to know where the fish are. So that's important. And these are post-smolts. So these are that early critical stage. There was a talk yesterday, Joe pointed that out. That first month, Leonard, that was yours. Yeah, that first month, that first 2 months, that is critical for the survival of these animals. So it's good to know where they are at any particular time. Yeah, so we can break that down into regions, and potentially we can bring that down into individual rivers of origin. And somebody yesterday talked about Hjelutne's paper in relation to the feeding. Leonard again, sorry. Imagine putting the stock, the region of origin to those fish. Because those fish that he's measured the gut contents from, they're from many, many different places. So I've actually been talking to Kelly. We're going to try and do that very soon. But that's the kind of stock specific. So back to this thing again, location and stock specific. So we've been doing something recently with some old data that I think Ken got us to do some time ago with West Greenland. So we're looking at West Greenland, European fish that turned up in West Greenland between 2002 and 2012. And again, I don't know, it was a big surprise or not a big surprise. 96, we would have expected about 50% of the fish to come from southern populations based on the productive potential. 96% of the European fish were from Britain and Ireland in West Greenland. I thought that's very interesting. Very few Norwegian fish. And again, significant underrepresentation of Icelandic fish. So the Icelandic fish don't seem to be there in the proportions that you might expect. Definitely the Norwegian fish aren't there in the proportions. And British and Irish fish dominate. So I thought, oh, this is great. Let's break this down. Where do these British and Irish fish come from? And there's three quite distinct geographical, genetically distinct areas. You've got the west coast of Ireland and Scotland. That's one group. You've got the east coast of Scotland, as you know, the guys that fish a bit. That's where the big 2C winter fish are. That's where the early run fish come from. And then you have the Irish Sea. And what's interesting is, when you look at the proportions, you see that you might expect 60, 70% of the fish should come from the south and east of Scotland, but actually only 43% of them come from there. You might expect 10% of the fish to come from the Irish Sea. We actually see 30%. And if you think of the numbers, so we've been looking at the expectations of numbers. So the kind of numbers of 2C winter fish that you see produced based on rod catches and so on, from the south and east of Scotland is about 43,000. Northwest of Scotland, northwest of Ireland. This is multi-sea winter fish now we're talking about. Multi-sea winter fish. There's about 12,000 from the west coast. And then in the Irish Sea, there's about 6,000. So in order to get from the ratios that we observed there, from 43% to Scotland to reduce from 60%, and for the Irish Sea to increase from 10% to 28%, it suggests that about 80% of the 2C winter fish that are produced in Scotland don't actually go to West Greenland. They're swimming around somewhere else. That has big management implications for how the ocean is used. So that kind of very simple statistical approach, just observe versus expect. And someday I'll show you the algebra behind that, but that's another day's work. But I thought what was really interesting from a genetic point of view is the legacy of structure. So this is some work that Eric Fitzboer has been involved in recently. And what they're looking at is stock structure that we see today related to where the ice was 20,000 years ago, 19,000 years ago, 18,000 years ago, right up to the present, when the ice relieved about 10,000 years ago. And that stock structure suggests that there was a refugia in the Irish Sea of fish, southern England, maybe the south coast of Ireland, northern France. And it would appear to me that that structure, that legacy, that behaviour is still conserved today. And it may well, it's a pity I can't show it, but it may well relate to where the ice was 20,000 years ago. So the salmon are still using the same route. Those southern populations are still using the same route that they may have established some time ago. So back to this idea, how much can they adapt? How flexible are they? How much is this thing hardwired into them? And just, I always love to plug, come here now, I was late getting on the show here, Peter. Anyway, I'm very nearly finished. So, look, we can do all sorts of things now. Now that we have the genome, the salmon genome, we can now start to link and look at these traits at a very specific level. And this is one study looking at one gene, variation of one gene, that accounts for some 40% of the potential for sea age and maturity, or explain sea age and maturity. Somebody talked about eDNA, again, genetics, loads of stuff there. So to conclude, location is important, and I think this just came out of the recent Gilby paper. Advances in understanding are most likely to be realised by integrating insights from genetic-based distribution and telomeric. So both are good. All these methods do different things, tell us different things, and they're all powerful. And I think the combination of those things is things that's going to be important. I see a lot of the physical tag stuff, the new technologies, as validation of what we might see at the more gross when we use the big numbers of fish. Validation, verification, mapping, and you get some insight into the behaviour. So I think it's a combination of the two. Stock origin, I think we're going to need higher resolution genetic baselines. That was quite crude, but still very powerful. But we can get much better. We can get down into the individual tributaries of the Tana, the Tano. That's available to us. That kind of mixed stock analysis is available. And the biology of migration, I think it's all to do with the level of hardwiring of the trait. We're going to have to work that out, because if they're not capable, if they're not flexible enough, or if there is not enough time, or the magnitude of the change is so dramatic that they can't respond, that's going to be important. And I just thought this is the last just little slide. A lot of the study we did on the SALSI project, we used pelagic trawls, experimental pelagic trawls, and they were fabulous for catching fish that are 20 centimetres long. But we want to know more. We want to go beyond the post-molt stage. So how are we going to do that? And this is stuff from Jack Ostova, I think it's from Faroese or Icelandic, I'm not too sure, from 1988. It was in Derek Mill's book at that time. And I just kind of superimposed some of the information that he got from long lining. And this is from the period after the post-molt. This is getting into the early winter and into the following spring. And he showed, you see the density of the boxes here, do you know the square that's superimposed in there? This was with long lines. And he started to look, and you can start to see the development of the feeding grounds. It's still quite conserved to a particular shelf edge, temperature profile. But again, we can start to move from post-molts then into older age stage. And you can even see, I don't know whether it's true, you can even this kind of bifurcation of the two things. And that might be where these multi-seed winter fish are starting to move into a different current. Anyway, it just gives you a little taste of where the future might be. But what is important to do that kind of work, or to bring that forward, we're talking about diversification of the sampling methods, maybe long line. The idea of a marine observatory. This is something we should be looking into the future. A network of sites or stations. The commercial fish guys do this all the time for cod and herring and all sorts of things, where they fish the same place every year. And over many, many years, you start to get this longitudinal profile, because anything in evolution or in response, you need to look at stuff over 10, not 10, 50, maybe 100 years. But you need to start now to start seeing those structures. Thank you very much.